In this question, we're going to describe the geometric relationship between lines and find the relevant equation. There are two straight lines L1 and L2. Moving point P maintains an equal perpendicular distance from L1 and L2. The locus of P is denoted by gamma. We need to describe the geometric relationship between gamma and L1 and find the equation of gamma. To find the geometric relationship between gamma and L1, we need to first determine the geometric relationship between L1 and L2. Let's consider their slopes, which are both 3. Okay, their slopes are the same. That means L1 and L2 are parallel. Then let's deduce the geometric relationship between gamma, that is the locus of P, and L1. For a moving point maintaining an equal distance from two parallel lines, its locus should be a straight line between the two lines that is parallel to the two lines and maintains an equal distance from the two lines. Therefore, gamma is parallel to L1. Part B, we need to find the equation of gamma. Do you recall with what information we may determine a straight line? 2 points or 1 point and the slope can determine a straight line. Since we know that gamma is parallel to L1, we have a slope. So what we should do next is to find one more point on gamma. To help us identify the next step, let's sketch it out. First, sketch the graphs of L1 and L2. Then sketch a graph of gamma, which is parallel to L1 and L2 and maintains an equal distance from them. Next, which point on gamma can we find relatively easily? How about the point it cuts the y-axis? But how can we find it? What is the relationship between the y-intercepts of L1, L2, and gamma? Let's deduce it. Suppose L1, L2, and gamma cut the y-axis at A, B, and M respectively. P and Q are the points on L1 and L2 respectively, such that PQ intersects gamma at M, and PQ is perpendicular to L1, L2, and gamma. Consider triangle APM and triangle BQM. Angle AMP and angle BMQ are equal as they are vertically opposite angles. PM is equal to QM as defined by the question. And angle APM and BQM are equal as they are alternate angles of parallel lines L1 and L2. Therefore, triangle APM and triangle BQM are congruent triangles with the reason angle-side angle. Hence, we can deduce that AM is equal to BM as they are the corresponding sides of the two congruent triangles. And that means M, the point where gamma cuts the y-axis, shall be the midpoint of AB. We can get the coordinates of this point from the equations of L1 and L2. Together with the slope of gamma, we can find the equation of gamma. So let's do it. We already know that the slope of gamma is the same as the slope of L1, that is 3. We can find the y-intercepts of L1 and L2 and thus the coordinates of A and B. Then we can find the midpoint of AB, 0, 2. Finally, use the slope-intercept form to find the equation of gamma. We get 3x minus y plus 2 is equal to 0. That's it.